So, in what way this feed-forward neural network is going to play an interesting role in the transformer architecture, we are going to explore. Transformer. As you know that I have already shared another, I think, 5 session recordings. Again, whenever time permits. There is no, first of all, there is no direct link to LSTM or GRU. Okay, only if I understand, I would follow transformer model like this. So there is no such connection. But getting some idea of this sequence modeling, popular model like LSTM, GRU models. In fact, traditionally we call this a recurrent neural network, theoretically. But practically, when we implement recurrent neural network, the most practical name we used to call it as, because RNN, traditional RNN has the limitations. So to overcome the limitations, we slightly modify the architecture and we name that as a long short-term memory. And one more modification we provide, that modification, we call this as a gated recurrent unit. These are nowadays, even though people, we are easily skip in 2025, before the transformer model, 2017 to 2018, this is the time, okay, the transformer model become a sensation in the AI research community. As you know that the popular paper, Attention is All You Need paper from the Google research team. At so many places, we are going to refer Google because Google are very pioneer in this field, particularly generative AI. So I would like to start the session with an interesting story about the Google research journey. Whenever I say a Google research team is very pioneer in generative AI space, particularly the transformer, because they are the one who introduced the transformer model to the world, right? Attention is all you need. But unfortunately, the core team, Google Brain research team, is completely scattered now. So that's a sad story. So what is the current scenario? I would like to hear from you how you are closely watch the business perspective. Of course, you need to learn all the technological know-how. What is the scope of each different transformer architectures, different models coming from Meta, OpenAI, until deep search model from Chinese models, Anthropic, and so on. Okay, every month we are getting a very interesting updates about different architectures. But once you generalized certain things, you don't need to worry about every new month, any new hype that is happening. You can easily embrace it. So all you need to know is what are all the core and essential things that I should solidify so that all these upgrades I can easily embrace without any difficulty. Even though a Google Brain research team is pioneer in this field, what is the sad story? Can you tell me? Anyone can share your views.
As you mentioned, they are split. They're working in different companies.
Okay, because of that. So because of that, what is the situation, current situation? Currently in the market where they stand, where Gemini stands, they came up with Bard and it became very big failure and immediately they rolled back and they renamed their model as a Gemini and they launched. Still, they have lost the market share. So when compared to who are the pioneer in this field, even though they are pioneer and they introduced the transformer model to the world, but who built the product first? OpenAI are the one who launched the product first, right? Unless otherwise ChatGPT hit the market, nobody were aware of such a very powerful use of a transformer architecture. Of course, it is in the research paper, but it should hit the market, right? So the very first sensation that happened is the ChatGPT from OpenAI, which hit the market. Then whole tech community start understanding and celebrating, hey, this is a transformer model, how powerful the transformer model. Look at the scope of. Then the moment the ChatGPT become a sensation, all of a sudden generative AI, okay, people start talking about the term generative AI. So what has changed from AI to generative AI? So this is a popular interview question. How do you differentiate AI and generative AI? Throughout our session, I will be giving a lot of scope for the interview questions. You can pen down those interview questions throughout the entire 12 sessions. You can have a handful of 100 plus solid 100 plus interview questions. You don't need to separately prepare for once again, you don't need to ask any AI model to, hey, give me 100 interview questions and all. So it is going to be a very good collection of interview questions. In fact, these are all the questions, real questions we have asked to some of the recruitment panel. I was part of those organizations. I do consulting, uh, entry level, middle level, and up to senior level. I was part of the interview panel. So these are all commonly asked questions. So how do you differentiate AI and the generative AI model? Because after ChatGPT sensation, people start talking about the generative AI, right? Until then, it was AI. So how do you differentiate these two guys? So the scope of AI is just prediction. Here also, it is, of course, it's a prediction, but the presentation is something different. Okay, under the hood, it is also doing a prediction. Okay, but whatever you are seeing in the final output is something like a generative responses. So in other way around, I can say, whenever you say a traditional AI model, you can build a regressor model or a classification model. The regressor model is going to predict a continuous output value, like for a tabular data set, or even for the image data sets. You'll be wondering, how come for the image data sets, what is the role of regressor? Okay, you keep thinking about it. You are very familiar with the classifier model for the images, right? So whenever I present an image, my classifier model has to predict this is a man or a person. Whenever there is a image of car, it should enter the AI model, can recognize this is a car, or in a single frame. In a single frame, there is a man, there is a car. It has to identify this is a man and this is a car. So that comes under object detection. So whenever I talk about the regressor, actually it has to localize the object in the screen, what we call this is the bounding box, these coordinates. So a neural network as a regressor, it is going to learn the coordinates. What is the starting row? Okay, what is the last row? From which column to which column my object is there. So during the training process, model will be learned as a regressor bounding box. We call this is a BB regressor, bounding box regressor. Even today, I have posted one small introduction about what is a bounding box regressor, what is localization. It's just a 10-minute video. Whenever time permits, you watch tomorrow because it's part of a computer vision course. And what is the scope of classification? Not only for the images, even for the tabular data set, it has to identify class label, isn't it? So regressor for the tabular data set, you have solved so many exercises like predicting house price, predicting blood sugar level, predicting rainfall in millimeter. Any continuous variable, you can build a regressor model. And for categorical, you build a classification model, right? So the goal of a standalone or classic AI is using a feed-forward neural network architecture, either a regressor model or a classifier. So I used to call this as either regressor head or classifier head. Why I'm calling this as a regressor head or classifier head? Because the feed-forward architecture, there are a lot of hidden layers. And finally, what you're going to do at the output side. That is going to decide your application, isn't it? According to your application, you need to design, I need to design the output head. We call this as an output head. If it is a regressor problem, I just connect only one neuron in the output side, only one neuron. If it is a classifier head, according to number of classes, if it is only two class, I'll be connecting only two nodes in the output. If it is a three classes, one hot encoded representation, three nodes. According to the number of class, we keep increasing it. So you are predicting the either class label or you are predicting some continuous value. That's all in your classical AI architecture, just like your any other ML algorithm. Then why we call this as generative AI? Using generative AI, we are going to generate some continuous response, particularly on the text data sets. We are generating continuous text output, isn't it? But even though it looks like a continuous text output for you, but it is like a one token at a time. It is going to, your output is going to generate one token at a time. So that means so we are going to understand the whole architecture in detail, but I'm just giving you, since it's an introduction session, I'm just giving you the bigger picture. Okay, get the bigger picture. So we are going to understand the whole architecture in detail in the form of, we have an encoder side of a transformer and we are going to have a decoder side of the transformer. One of the recorded videos shared to you, try to watch I think session 4 or session 5 of the recordings, I guess. Using LSTM, two interesting applications, I think last session, I think. Using LSTM architecture, okay, two interesting use cases I demonstrated. Language translation, English to French or French to English, whichever the way. So that is also encoder decoder style of architecture, but it is designed using LSTM module. But instead of LSTM, we are going to use a transformer architecture. Okay, so only the internal architecture is going to be different, but the purpose is same. Whatever the LSTM based encoder decoder architecture I have used for that exercise, the goal is to convert input side. Okay, input side, we are going to give a sequence of input. Output also, we are going to get the sequence. So hence it is called as a sequence modeling. So your generative AI, why we call it as generative AI? Because in the output side, you are not predicting just a single label, or you are not predicting a single continuous output value, but you are continuously generating, okay, output. This is one token. This is another token, another token. And once again, this token is a new terminology for you. Maybe few of you have already having some idea about what is token. For time being, please understand it is a individual word, but it's more than an individual word, right? So once I'm going to introduce what is byte pair encoding, you will have a complete understanding of how your token looks like. Okay, for time being, your individual word is a token. Okay, so this is the first word, second word, third word, and so on. So your decoder is going to act as the output side of the decoder. I mean, you have so many layers. We are going to discuss in detail what these layers are going to do. Your input sequence is consumed by this encoder, and this is communicated to the decoder. And your decoder also going to digest all these pieces of information. And finally, what is the output head of this decoder? At the end of the day, I have to attach a regressor head or a classifier head, isn't it? This fundamental idea of a neural network is not going to change. This is a fundamental idea. So what, again, this is a popular interview question. I think in the last half an hour itself, this is the second interview question I'm talking about. in the generative architecture or in general any transformer architecture in generative mode, will there be a transformer architecture non-generative mode? Yes. What do you mean by non-generative mode? I can build an application only with encoder only transformer architecture. Okay, it is going to work as a classic AI model. What is classic AI model? It is going to predict a single class. Like that is how we have a popular applications like a sentiment analysis. So what we call this is a many to one application. Many to one. What is mean by one? One outcome. Input you are giving the sequence, but when you use encoder only architecture, this movie, okay, this movie is great. I need to predict what is the label this review should belong to. This is a positive review. Your encoder only architecture is going to make a decision. Either it is a positive class or a negative class. So whenever I design encoder only transformer architecture, I am going to use it as a classical AI prediction model. Okay, we are going to come to that also. But in general, whenever transformer architecture is designed for generative purpose, what is generative purpose? Question answering, right? You give a question, it gives answer. So your input is a sequence, output also sequence. Translation task, English to German or German to French or any language, one language. GPT-3 was launched. GPT-3 were able to support around 80 plus languages. You can ask question in 80 different languages. GPT-3 was able to answer it. Thereafter, all the versions like a 3.5, 4, 4 Omni and all those things, they have increased the number of languages. Now it is close to 150 different languages it supports. Okay, 4 and above. Similarly, if any small language model, if you consider like a Llama model, okay, now Llama 3 is there, Llama. In Google small language model, which is a popular Google small language model, Yamma. So, so small language model, the model parameters somewhere between 2 billion, okay, 2 billion to, I can say 7 billion architectures are very popular for Llama. 2 billion to up to 15 billion, we consider as a small language models because model parameters involved is just 2 billion to 15 billion. Whereas a GPT, if you consider GPT-3 large language model, just a 3 version itself, it is the lowest version, right? 175 billion. Look at the size of the model parameter. And relatively, as you go with the higher versions, the model parameters is going to grow. The model parameters is directly proportional to the architecture, isn't it? More and more layers you keep on adding, obviously it's going to contribute more model parameters. Why you need more and more layers? Because you are going to build a powerful architecture, multitaskers. Multitasker, not only multitasker, multi-domains. If you're asking a question in biotechnology, it's answering. It is when you're asking a question in physics, it is answering. If you're asking a question in a coding related query, it is answering. So multitasker as well as multiple domains. So we required an enormous volume we used to give to those model during the training process. So model has to generalize the different domain as well as the different task. It has to understand the translation task. It has to understand the summarization task. You are asking the model to, hey, can you write a story about this topic? So for each and every activity, we need to give several millions and billions of training records for the model to understand. So for those cases, only if that huge architecture can memorize or understand those kind of multitasking as well as across the multiple domain. So nowadays, there are so many techniques came, particularly after DeepSeek. Okay, how to efficiently understand multitasking with reduced sizes, all those things. We are definitely we are going to touch upon all those topics moving forward, particularly the second half of our session. Second half in the entire the second half of the course, particularly session 7, 8, that time and all, you'll be very well versed understanding different architecture. So you are able to appreciate what are all the nuances these deep search model, DeepSeek model, particularly they came up. They are one of the biggest claim is it is computationally fast and it occupies less memory, right? And even with the small number of parameters, it is competing with GPT-3 model. So how those things are possible even with the compact model, and how you can transfer the knowledge from the bigger model to condense the knowledge to a smaller architecture. All those things we are going to learn in this course. But fundamentally, what you need to understand here is, again, I'm coming back to the question, what is the head of the generative type architecture? So output, I'll be tapping the output at the decoder output side. Okay. Whenever I design encoder only architecture, I'll be tapping the output here itself. But when you build a sequence to sequence applications, generative type applications, okay, I don't tap the output here. Okay, rather I do a connection to the decoder model. What kind of connections and how we are going to do, we are going to explore in detail. Okay, but time being, please understand, we are going to communicate to the decoder, and from the decoder output side, I'm going to tap the output. Okay, so once again, let me put this like this: encoder side, decoder side. Encoder side, I have given maybe a large paragraph. Imagine maybe 1,000 tokens. Okay, maybe 1,000 words. You say that summarize. So summarize to 50 words. This is going as an input here. It is communicating to the decoder. Hey, this is what the paragraph, the large paragraph, large story given by the user. You are supposed to summarize this. So decoder understand that. So decoder is going to produce the summarized output. Okay, this is just one application. Like any application you can think of, a question answer chatbot or translation, anything, explanation. But what you need to understand here is, what is the head of the decoder? Head of the decoder in the sense the output layer. What kind of head do you think? Definitely, it is not a regressor head, right? We are not going to predict anything, a numerical value, a continuous numerical value. So regressor head is ruled out, right? So obviously a classifier head. The moment it comes to a classifier head, the next question naturally comes over here is, what will be the size of the output layer? If I ask the same question here, you can easily answer. For sentiment analysis, if I'm going to predict a positive sentiment or a negative sentiment or even a neutral sentiment, 3 classes, here my output head will be 3 nodes. Okay. Or I can do a text classification. I have 5 different text. A news article, maybe one news article is a political news, another news article is a science news, another news article is a religious, sports, and medicine or something. Understanding the content, it has to classify which type of text. With this comes under text classification. Since I have 5 different genres are there, so my output node will be 5. So beyond this, we have 2 more interesting applications also there. We are going to talk about that. So in simplicity, in the encoder side, if I ask you what will be the number of nodes in the output side, we can easily tell according to the application, nature of application. If it is like a sentiment analysis, 2 nodes or 3 nodes. If it is a text classification according to the genre, you can easily fix. But for the generative task, what will be the size? Any idea, any opinion, any thought process? How do you decide the size of the output?
Corpus, the entire corpus in
Very good. Entire corpus. So what I can say that entire corpus, technically here we call this as a vocabulary. So the entire vocab, and there's an interesting way they have optimized the size of the vocabulary. Because what is the biggest challenge of maintaining the English vocabulary for not only English, for any language? Because your vocabulary size is exponentially, it will grow. Even if you consider for the English, for the normal communication, okay, normal English communication, it is 15K to 20K words. Even if you consider the proficient level speaker, because they use very rich set of vocabularies, isn't it? When we Indians wants to do masters in Western countries, they need to clear TOEFL and all. At that time, you might have prepared like a different vocabularies, because in a normal communications we never use those synonyms, isn't it? But for the examination purpose, you study. Okay, this is in commonly we use certain words, but there are so many other synonyms also you'll be learning as part of the vocabulary. So in a communicative English, we hardly have 15K to 20K words only. But when people build the language models, okay, they have not taken only the communicative English words alone. They have taken the literatures also, English literature. For example, if you consider the Shakespeare, the entire volume of the Shakespeare's literatures, okay, there will be around 30 to 35K vocabularies is there if you take the literatures and all. You think about in your own mother tongue also. Every mother tongue, we have also a lot of literature period articles are there, but we never use the words. It is being used in several years before. In the literature language, we never communicate within our family or with your friends and all, right? It is whatever the language we are speaking is a very communicative, colloquial language. But in the literatures, we have lots of words only in the literatures being used, but not in the communication. But while build the model, they have used the complete literatures. Even if you take literatures and other special tokens, hashtags and other email IDs and different website notations, put together all, okay, it will come easily 50K to 60K tokens. But and if you can, as you are going to include multiple languages and all, you think about the volume of this corpus, how exponential it is going to grow. So to optimize this vocabulary size is one of the biggest challenge, because every time your decoder is going to produce the output something like this, generative AI, your final decoder output is going to predict YCAP given start of the sentence. SOS is a special token. Okay. So the special token will be act as a trigger token for the decoder side. So as soon as the user has given the query, okay, this trigger token, which is at the decoder side, it will trigger the decoders to start producing the output. Maybe assume that the very first word model is predicting the token the. So we used to use a term called recursive generation. Recursive. Please don't confuse the term recursive with feedback. So we are not going to talk about anything related to the feedback. There is no business for feedback architecture. That is one of the very biggest breakthrough. One side, until 2017, all the researchers have struggled with RNN based architecture in the form of LSTM and the GRU. They were able to successfully build the applications, okay, one application at a time. For example, by using LSTM, they were able to build a machine translation. Using LSTM or GRU, they were able to build a chatbot. They were able to build another model like a summarization. But not all in one. That is very challenging. So that is the reason LSTM based architecture is not successful. It does not hit the market with a product. But theoretically, you can build all the applications, whatever you build using a transformer. You can also equivalent, I'm not saying easily, you can also equivalently do with LSTM based architecture. Theoretically, it's possible, but it is not scalable. That's the difficulty, because your LSTM based architecture is going to consume your input paragraph. Say, for example, the same 1,000 token example I have mentioned over here. One by one token only it is going to consume. One token, because one token at a time it is going to consume. But whereas one of the biggest difference here is your transformer architecture is going to consume the entire 1,000 tokens in parallel. It's a parallel consumption, whereas your RNN based architecture, it is a sequential consumption. Consumption in the sense the processing. After getting the input to token, what are all the steps it is going through, right? Those steps I'm talking about the consumption. If you want to know the detailed step, please watch the shared recorded videos whenever you get a time. But once again, I'm saying there is no direct connection to it. Only if you learn that you are able to follow this, nothing like that. You'll get a different perspective. Okay. Okay, this is how the LSTM, okay, these are all the limitations of LSTM. That is why the researcher has moved to transformer based. So your idea, your horizon will grow. Different dimensions you will get, different perspective you will get. So on current state of the art technique, for nobody uses LSTM for any language modeling. Because of that, don't say that LSTM is dead. Okay, people think that LSTM and GRU is dead. But still, LSTM and GRU are playing a very good role in the numerical sequence, particularly for forecasting problems. Still, there are interesting applications people are developing for stock market forecasting, rainfall forecasting, sales forecasting. There you need to do a numerical forecasting, right? There we are not going to use a language models, transformer. So that still LSTM based models are doing a good job. But coming to the language model, of course, it's a dead. But still researchers are looking at an option. Is there a way to integrate LSTM capabilities also? It is in the research perspective only. No successful model came out. People are trying to bring some hybrid architecture, all those things. But it's a long way to come and hit the market. At least it will take another 2 to 3 years. It may happen or it may not happen. So in the output side, we are going to have the output node, which is one hot encoded. Okay. Let us roughly, we consider this is a 50K tokens, which is my vocabulary, 50,000. At one point of time, your output side decoder, it's going to find out which token gets the maximum probability whenever the trigger token hits. Okay. For example, this is the node reserved for the token, which got the highest probability. That's the reason the first token, it predicts as the. Now it is going to behave in a recursive manner in the sense, next instance, along with the trigger token, SOS, and it's going to hit the decoder input side. So this is how your encoder decoder architecture. The moment you give the input along with the prompt, encoder has consumed your entire prompt along with whatever the paragraph you have given. It is communicated to the decoder. After that, the job of encoder is over. Later on, your decoder is going to produce your output sequences in a recursive manner. Recursive manner in the sense, to kickstart the decoder, start of the sentence. This is a special token I told you. The special token will kickstart this decoder, and the decoder will produce the first token, right? Once it predicted this, then recursively, this will come as part of the input sequence. That means your input sequence to the decoder will keep growing till the time decoder decides that, hey, I have produced the meaningful output. The moment the decoder thinks that I have produced the meaningful output, the last token, it will say that end of sentence. The moment it produces the last token end of sentences, it say that, hey, this is the response for your question. So then next instance, it is going to hit the decoder once again, start of the sentence, and the um, say the next word it predicts cat. Then again it's going to come recursively. SOS the cat. What is the likelihood of the next word? So which a token or which node is getting the highest probability? It's keep predicting the node which gets the highest probability. So your output head, it's a classifier head. The number of nodes is equal to the vocab size. But this vocab is cleverly planned using a clever idea called as a byte pair encoding. As I told you, right? Because for to accommodate multiple languages and across the literatures, if you wanted to imagine, I need to reserve one node for each word means this vocab size will go enormously. As this size grows enormously, my computational speed will be very, because at every point of time, my decoder has to find out among the 50K nodes, which node got the highest probability. It has to pick that. Again, it will going to put that in a recursive manner. Hey, this time it is SOS, the, and cat. What is the next word you are predicting? Which node has got the highest probability? You tell me. Every time it has to go and find out among the 50,000 nodes, which is the highest. Imagine if it grows exponentially, 1 lakh nodes, 2 lakh nodes and all, it will slow down the process. So I no need to reserve each and every node for every word or every complete word. I no need to keep one complete node. For example, a cat, one node. For cats, plural, it's a pointless. So I'm just giving you an outline of byte pair encoding. The next session, we are going to talk about this in detail. Okay. First half an hour or 45 minutes, I give a very big picture and we are going to break down each component into detail so that you will get in what direction we are moving. You'll get an idea. So we are going to connect all the dots. Say, because this is a plural, right? So for plural form, I don't reserve a separate node. The idea of the byte pair encoding is your individual alphabets also a part of your vocab list. Lowercase a to z and uppercase a to z. For example, according to the context, I need to, the next word is the cats. Okay, because the input, the question is asked about a story about, the context talks about the cats. It's a plural form of the cats. So in the output side, it is referring to the cats, not cat. That means your one node is reserved for cat, another node is reserved for the character S. Understanding it is a plural form of the cat. Okay. For us, in our output screen, it looks like continuous words are being generated, right? But internally, how under the hood, how it works is cat will generate first. Afterwards, the S will come attached to this. And for us, it looks like a cat's in the screen. But internally, first cat followed by S. The S will come and attach to cats. Because S is a common, wherever I need to attach or refer to plural form, this yes should come and attach. So likewise, it is going to break down to the phonetic meaning, sounding of the English sounds. Phonemes, we used to call it as in communicative language, we call it as a phonemes. And for the physical structure, how a particular word has to break down into two pieces or three pieces, how it is, model is going to decide that. So the technique called as a byte pair encoding is a special technique. So there will be a separate training will be given to understand the vocabulary itself. So for the given piece of a training record, say for example, you are going to build the model from the scratch, but nobody is going to build the model from the scratch, first of all. Unless otherwise, you should be a part of research team of OpenAI because, or a Meta or Google or many startups, now they come up with a new model, they build the model from the scratch. That means whenever you build the model from the scratch, you need to provide the training corpus. See, even though if say for example certain models are open source, even the open architecture is given to you, what is the biggest challenge? when GPT launched the model GPT-3 is a open source. Anybody can see the number of layers, model parameters, 175 billion, everything. It's a transparent. Everybody can understand the architecture. But the later versions are not open sources. 3.5, 4, 4 Omni, O1, O3. They are not open source. Even though, say, for example, say GPT is saying that, hey, this is what the internal architecture, the completely transparent, it is given to you. How many transformer layers? What is the embedding size? The complete transparent architecture is given to you. Is it possible for, what is the biggest challenge for you to come up with your version of GPT-4? What is the biggest challenge? The training data. That is where the company is going to take an edge over another. What is the data you'll be using to train the model? Of course, there are a lot of free resources. One of the biggest strength I personally feel to OpenAI, initial days, like now there are a lot of competitors came in the first 2 years. The first 2 years, the two closer competition were Google and of course the Meta also come in the small language space. But in the large language space, one of the close competitor is only the Google is the close competitor. The challenge is, yeah, the biggest advantage the OpenAI they have, I think at least 40 to 50% of the revenue will go for the paid resources OpenAI they have used for their model. Not only the free resources, openly available resources. So they have proved, okay, rather the volume, the quality of the data really matters. So that is what the tug of war, at least in the first year. Okay, so Google research team is in a lot of pressure to launch their model soon after OpenAI hit the market. And in a hurry, they have launched the first version of the model, and there is some technical hiccup, and they withdraw the model, and again they rebrand it, and then it came in the form of a Gemini. The story, you know it. Immediately, OpenAI criticized Google. It's okay. It's not about the volume of the data. Hey, OpenAI has criticized Google, saying that you have hugely depend on Reddit data. Reddit is, that huge repository has lots of Q&As, like general question answers you have, like a Quora. Reddit is a very huge repository for Q&As, different fields. So you're too much relied on the Reddit database. Okay, it's not about the volume. That is the one critical comment mentioned by the OpenAI for the withdrawal. So till now, OpenAI, they're believing their USP is the quality of the data, what they're using it. So for that, they are paying a huge um, copyright fee for those data they are using it. So they are continuously upgraded by many of the individual researchers who post, or many uh, journalists who post a lot of articles, right? A lot of articles. How many of you are using this option in the LinkedIn? LinkedIn comes with you can contribute to LinkedIn in the form of answering to the queries, isn't it? Have you contributed? In turn, LinkedIn is going to use it to customize their own AI system. So already they have a generic AI model. Okay. It is being trained on some open Q&As database. And why LinkedIn is going to approach different experts. Say there are 5 lakhs experts. Out of the 5 lakhs experts, maybe 5,000 experts are very eager to contribute to the LinkedIn. Some of the popular questions, technical questions in different fields, from data analytics to data science to almost different fields. Um, um, Crypto and chemistry, physics, biotechnology, pharmaceutical, lots of fields. So for this is the standard question. Okay, what is your perspective? What is your perspective? Like each and every people, they're trying to give an answer in a different perspective. So all those are okay as a free knowledge resource for the LinkedIn. They will be feeding this rebuild the model periodically. Okay, this model training, of course, the kind of it's not a full model training, PEFT LoRa technique. That is also we are going to learn. This we call as a fine tuning. So instead of changing 7 billion model parameter, you just work on only 1.2 million parameters. Working on 1.2 million parameter is far less computation time and compared to 7 billion parameter, isn't it? So that's the strategy we use it in the perf LoRa fine tuning technique. So this is the like a free contributors. But however, OpenAI, they are using the paid contributors, lots of paid resources. They are using it for build the model. So copyrighted content. So royalty fee, they are paying it. So that is one differentiator. Still, OpenAI, they believing they have a slightly upper edge over Google. So this is the bigger picture of what is the difference between the AI and generative AI kind of products. So generative AI, we are using it for mainly for sequence generation, isn't it? Sequence generation. What are all the things comes in the sequence generation? Your Q&A, translation, summarization, essay writing, all those things comes in the sequence generation.